Alright, so we're going to take a look at creating some single variable equations, okay? So, the main things you want to look at here is you want to figure out what you know, okay? So, you create an app that records how many times you use social media. Backtracking your data, you found that you've already logged in 27 times in the past weekend, okay? You check it a week later and find that you averaged 34 per day, and how many days will you have reached 1,013? Okay, so we know our goal, what we're trying to see how long it gets to. We know an average that every day we're posting 34, right? We also know that in the past, before we started tracking it daily, we started with 27. Okay, so when we're thinking about creating an equation, it's best to think about where do we start and how does it grow. Okay. So what we don't know is how many days. So that's our variable, we'll call it D. Okay? So we want to know how long it'll take us to get to here. So I know that that's what I want to be equal to. I also know that I already started with 27 before I started tracking it daily. So then that first day after 27, I added 34 to it. Then the next day, I would add 34 more. And the next day 34 more, and so on for this amount of days. Okay? Well, repeated addition we write as multiplication. We don't know how many there are, so we use D. Okay? So there's our equation. Now, can we solve this to figure it out? Yeah. Subtract by 27. Okay? We end up with 1,013 minus 27, which is 986. Okay, equals 34 times D. Then to separate, we divide by 34. And we get 29 equals D. So in 29 days, we'll hit that goal. Okay? And that's how we created the equation to do that. Now, we could do this problem without an equation, but part of the practice here is figuring out how to make an equation. So let's keep going. So, Albertimus is looking into adding to his Unicorn Patrol collection. He currently has the original 5, but since the show has ran through many different Unicorn Patrol members, he's looking to collect them all. With his allowance, he figures that he can buy one every 2 years. How many years until he has all 14? So again, what do we know? We know he's got 5 of them already. Okay, so he's starting with 5. Okay, do we know how it's changing, how it's growing? Okay, well, he can buy one every 2 years. Okay. So that's how it's growing. Okay, do we know where we want to be? Yeah, our goal or our end result is to be at 14. Okay. Now, what don't we know? We don't know how many years it's going to take him. We'll call that Y for years. Okay. Now, this one's a bit trickier, so it sometimes can be useful to think of a T-chart. So we're thinking, okay, in years, so starting at 0 years, how many did he have? Okay, well, he had 5. That's where we started with. Okay, then in 2 years, what are we going to do? We're going to add one more, because he'll buy one every 2 years. So we'll have 6. Year 3, none. Year 4, we'll have 7, and so on. Okay, and we can use that to figure it out, the answer, but if we want an equation, we can't. But think of it this way. If in 2 years, that's how long it took him to get 1, okay, how much money did he save up halfway through after 1 year? Well, he would have half of it, right? So it'd be 5.5. So every year, we're adding a half. Okay, so to get to 14, we know we started out with 5, and we're adding 1/2 every year. We could also rewrite that as y over 2. Okay, now can we solve that? Yeah, 14 minus 5 becomes 0, so y over 2 equals 9 times by 2. That cancels out. We get y equals 18. So it's going to take him 18 years to get there. Alright, the average person spends about $120 eating fast food per month. In how many months will the average person spend $2,400? Okay, so we know every month we're spending 120. So do we start at 120? No. That's how it's growing, right? We also know that we want to see till they get to that amount. So that's kind of our goal, what we're reaching. So I know 2,400 is going to be equal to something. Okay. What don't I know? I don't know how many months. We'll call it M. But I do know that I'm adding 120 every month. Okay. So shortcut addition, because we don't know how many, we're going to times it by M. Okay. Do we have anything else to add? No. There's our equation. How do we figure it out? Divide by 120. We get 240 divided by 12, which I believe is 20. It is. So, in 20 months, we'll have spent that much eating out. Okay? All right. Okay, Ethelbert is saving up for college. He currently has $400 and is making an additional $30 each week at his new job. How many weeks, months, or years until he will have enough saved up to attend UVU? Okay, well, we know he's starting with 400. Okay, and every week he's going to earn 30 more. So that's how it's growing. Okay, do we know how much it's going to cost to attend UVU? I don't know. So let me look it up. Tuition of UVU. All right. So as of 2015-2016, here is how much we've got. Okay, pulled this straight off of Google, so hopefully it's accurate. Okay, so let's say we're in state. Okay, so it would be 5,386. Okay, now I'm assuming this is probably just for one term, would be my guess. Okay, and it depends on how many classes you're taking. But we'll just say for one term, okay? Because that's all he needs, maybe. Make it easier for us. So, we know he already has 400. And he's going to add 30 every week, okay? So, if it were out of state, it would still be 400 plus 30W, but it would just look different. So we subtract 400 from both, okay? So we end up with 4,986 equals 30W. Divide by 30. And we get 166.2 equals W. So 166 weeks. Okay. Now if we did the other one, 15,202 minus 400, gives us 14,802 equals 30W. Divide by 30. We get 493.4. Okay. Now, how would we change this into years or months? Well, months, we'd take 166.2 and probably divide it by about 4. So it'd be about 41.5 months. For years, I'd take 166.2 and divide it by 52, because there's 52 weeks in a year, on about 3.2 years. And I could do the same thing for 493.4, divide by 4, roughly that's 123.4 months, and then dividing by 52 would be about 9.5 years. All right? Okay. Next question. Horatio's mom is tired of his toenail clippings being stored in the basement. They estimate that he currently has 270 pounds of toenails, not all his own, in the basement. His mom wants 15 pounds removed every day. How many days will it take to get rid of all the toenails? So we know he currently has 270 pounds, that his mom wants 15 pounds removed every day. So this is where we're starting. This is how we're changing. Okay, and what's our goal? Well, to get rid of all would be 0, right? So we start with 0, and we go 270. We're going to subtract 15 our unknown was days. Okay, but it's 15 per day, so we can just go 15 times d. So subtract 270 from both sides. We get negative 270 equals negative 15d. Divide by negative 15. And we end up with, I believe it's positive 18. So in 18 days, his basement will be cleaned out, and hopefully nothing else will take its place. Alright, let's come back to this one. James earns $15 per hour as a teller at a bank. In 1 week, he pays 17% of his earnings in state and federal taxes. His take-home pay for the week is $460.65. How many hours did he work? So what don't we know? That's how many hours. We'll call him H. He worked. Okay, what we do know, he's 15 per hour, and he pays 17% in taxes, and he brought home this much. So we know it's equal to 460.65. Now, can we figure out his total pay? We should be able to, because we know it's 15 per hour, so whatever the hours are, we times it by 15. Okay. We also know that 15 times H is 100% of what he makes. But we're going to subtract 17% of that. Okay, so he's actually only making 83%. So what's 17% of 15? Well, I can go 15 times 0.17, and it would be $2.55. Okay, so we could subtract from 15 2.55. Okay, or if I took 15 and times it by 0.83, I should get to the same thing. Yeah, so I'd end up with $12.45 times H. Okay, that's how much take-home he's actually earning each hour. If I go 15 minus 2.55, it's still 12.45, so same thing. Then to solve, just divide by 12.45. So I go 460.65 minus 12.45. Oops, divided, not minused. Big mistake there. And we get 37 hours is how much he works. Okay, those percents can be kind of tricky, but they're not as bad as you think they are. Alright, Brianna has saved $600 to buy a new TV. If the TV she wants costs $1,800 and she saves $20 a week, how many years will it take her to buy the TV? We're looking again for years. What are we told? We're told that she has $600 already. She needs $1,800. Okay, she's saving $20 per week. Okay, now we want to get to years, but we're in weeks. But let's figure out how many weeks, because we know in a year there's 52 weeks. Okay, so subtract 600, we get 1,200 equals 20. Divide by 20, and we get 60. So it's going to take 60 weeks, so we can times that by 60, and that should tell us. So 52 times 60. Oops, not times. Why did I say times? Weeks divided by 52. There we go. 60 divided by 52. And we get 1.15. Okay. So about 1.2. So that would be 1 year. And then 0.2. Well, there's 12 months in the year, so 12 times 0.2 would be 2.4, so about 2.5 months. So, bit over a year. Alright, suppose two brothers who live 55 miles apart decide to have lunch together. Okay, so here's one brother's house, the other's. We know they're 55 miles apart. To prevent either brother from driving the entire distance, they agree to leave their homes at the same time, drive toward each other, and meet somewhere along the route. The older brother drives cautiously at 60 miles per hour. The younger brother drives faster at 70 miles per hour. So how long till they meet? Okay, so we're dealing with, we know their speeds, we know the distance, we don't know the time. Okay, so distance always equals rate times the time. Okay, we know our distance is 55, so 55 equals, now we know our rates. And because they're covering the same distance, it's like they're traveling together. So I know that I can add their rates together, and then that would be multiplied by the time to equal 55. So there's my equation. Then we divide, and we get about 0.42 equals t. Okay, so 0.42 what? Well, we're dealing with hours here, so 0.42 hours, which if we want it in time, or in minutes, times by 60, and so I get 0.42 times 60, which is 25.2 minutes. So almost a half an hour. Okay? Alright, now, if we were thinking about units, okay, the rate at which water fills up a swimming pool, probably going to be something like gallons. Okay? We don't really have much bigger than gallons, but it would be that. Cost of tiling a kitchen floor. Cost is usually in dollars, hundreds of dollars maybe. Not sure what they mean with the money. Average speed of a falling object. Okay, if something's falling, generally it's feet or meters per second, because things fall fast. The rate at which a snail travels across a sidewalk. Snails are pretty slow, so maybe I'd say feet per hour or inches per second. Okay, or hour or minute. Various ones that I would do. The rate at which a room is painted, probably hours, amount of space per hour, square feet per hour, something like that. Okay? Alright, let's tackle that last one that we skipped before. Okay. So, to celebrate graduation, you and 4 of your closest friends have decided to take a 5-day whitewater rafting and hiking trip. During your 5-day trip, 2 days are spent rafting. If the rafting trip covers a distance of 60 miles, and you are expected to raft 8 hours each day, how many miles must you raft each hour? Okay. Then, for the hiking portion of your trip, you and your friends carry the same amount of equipment, which works out to be 35 pounds of equipment each. For extra money, you can hire an assistant who will carry 50 pounds of equipment. Each assistant charges a flat fee of 50 and an additional 22 for each mile. The total amount you would have to pay the assistant is 512. How many miles will your group be hiking? Is it worth hiring 2 assistants to help you and your friend carry the equipment? Justify your answers. Okay, so a lot here. Let's start with the first bit. Alright, so you and 4, so there's 5 of us. We know that there's 5 people, okay? We know for that 5-day, 2 days are spent rafting. So the rafting in 2 days, we're covering 60 miles. Okay, and you're expected to raft 8 hours each day. How many miles must you raft each hour? Okay, so how many miles? So we'll call that M. Okay, so we have to go 60 miles in 2 days. Okay, and you are expected to raft 8 hours each day. Okay. So we're traveling for 8 hours. So per hour, how far do we have to go? Okay. So, if we take a look at this, I know that my 60 per day, okay, or, there's 2 8-hour days, so I know that I'm traveling for 16 hours total. And in that time, I need to cover the 60. So I could go 60 divided by 16 should equal how many miles per hour I need to go. Okay. Could have also split 60 in half to 30 and went 30 divided by 8 would equal how many miles I need to go. So I do that and we get 60 divided by 16 equals 3.75 miles per hour. Okay. Now, the hiking portion. Okay. So, we can hire an assistant. Okay. So, we know that between the 5 of us, we each need to carry 35 pounds. Okay. We could also carry someone to do that. They charge $50 and $22 each mile. The total amount you'd have to pay is $512. How many miles will your group be hiking? So, if we were to pay the assistant $512, okay, you had a flat fee of $50 plus $22 per mile. Okay, so if we figure this out, he started with 50, then we're adding 22 per mile, and we paid him $512. So then I subtract 50 and get 462 equals 22m. Divide by 22, and we get 21 miles is how far we're hiking. Okay. So, is it worth hiring 2 assistants to help you and your friend carry the equipment? Okay. So, we would have to end up paying $512 twice, right? So $1,024. Total equipment we have is 35 times 5, which is 175. Okay. If each of them are carrying 50 pounds, that's 100 pounds off, so that's 75 pounds divided by 5 means we'd each only have to carry 15 pounds. But we'd have to charge an extra $1,024. Okay? So is it worth it? Well, it kind of depends on what you think. I personally wouldn't pay that much for just people to help me hike. They'd have to be carrying me if I was going to pay that much. And then if I was being carried, what's the point of actually even hiking? So anyway, so there we go, guys. And there's some examples on solving equations, solving equations, but creating the equations so that you can use them to solve things. All right, there we go.